So here we see our log properties again. So the log of products we can separate out into this log of the sum of the two elements of the product. So if I have x times y on the inside, I can separate it into x, log of x, and then log of y being added together. For the log of quotients, we can translate that into a subtraction question, so separating out the pieces that are being divided into separate logarithms and subtracting. And then we have that log of powers that allows us to bring the exponent to the front. So we can also work in the opposite direction, where we start off with what we see on the right in all of these circumstances and move towards what we see on the left. So instead of taking a logarithm and expanding it, we can take multiple logarithms that are being added and subtracted or have a coefficient in front of them and then rewrite them as a single compact logarithm. So in the first example here, we can see the string of 3 separate logarithms that are being added and subtracted. But the first thing I'm going to do is I'm going to move these coefficients inside and make them exponents on the inside of the logarithm. So we'll have log base A of x to the 3rd power, so moving that 3 coefficient to become the exponent on the x, minus log base A of y to the 2nd power, so the 2 coefficient becomes an exponent on the y, and then plus the log base A of z. And so now we've got this collection of logs that are being added and subtracted, so we can combine them into a single logarithm of base A with anything that's positive going to be in the numerator of my expression inside the logarithm, and anything that's negative is going to end up in the denominator. So the log base A of x cubed, that's positive, so that's going to go up top. Then we have minus the log base A of y squared, so the y squared is going to end up in the bottom. And then finally we're plus the log base A of z, so that's positive, so that's going up top. So our expression can be combined into the log base A of x cubed z over y squared. In the second example, there's a couple different approaches that we can take, but I think our best bet is to distribute this 1/2 to both pieces first, then we can use that as a coefficient that can be moved inside as an exponent, instead of combining what we see inside first and then multiplying by the 1/2. But if we did that, we would be just fine. But if we distribute, we end up with 1/2 times the natural log of x plus 1/2 times the natural log of y squared. So now I'm going to take these 1/2s and move them inwards as exponents on what's on the inside. So we'll have the natural log of x to the 1/2, and then plus, if I move that 1/2 exponent inside, it's going to be raising this y squared to the 1/2 power. So we're going to have natural log of y squared to the 1/2. So if we work on this piece over here a little bit, I'll leave the natural log of x to the 1/2 alone for now. But for the second piece, when I raise an exponent to an exponent, we're going to multiply those. So I'm going to have natural log of y squared to the 1/2, so 2 times 1/2 is just 1, so it's going to be the natural log of y. The other thing I'm going to do here before I combine these into a single logarithm is I'm going to rewrite it in radical form instead of fractional exponent form. We generally write things in root form when we can. So natural log of x to the 1/2, I'm going to rewrite that as the square root of x. Remember that a 1/2 power means the square root of x. And then we've got plus natural log of y. And so now finally, since these are 2 logs that are being added together, I'm going to combine them into a single logarithm. So we're going to have the natural log of, and then inside the logarithm we're going to multiply those 2 pieces, root x times y, and then just being careful to make sure that that y is not underneath the square root symbol, only the x is.